Hello everyone and welcome back. My name is Mr. Kowalt, and in this video I'm going to go over the first practice problem for Charles's Law. One of the things I forgot to mention in the other video that's going to be very important is in the gas laws, whenever you have certain units, it really doesn't matter what units you use because they're going to cancel out anyway. So for example, in Boyle's law, you're using pressure and volume. So you could have pressure in atmospheres, pascals, kilopascals, torr, whatever, as long as the units are the same and they cancel out. Same goes for volume. You could have liters, milliliters, whatever. As long as the volumes are the same, the units are the same, so they will cancel out. However, when it comes to temperature, you have to have your temperature in Kelvin. And the reason for that, or one of the reasons for that, is because Kelvin is the absolute temperature scale and you can't get negative numbers from Kelvin. So with the Fahrenheit or with Celsius, you can get negative numbers, and when you put negative numbers into the equation, you can get negative volumes, which makes no sense whatsoever. So you need to convert your degrees Celsius to Kelvin before you plug it into Charles' law or any gas law that requires temperature. Temperature always has to be in Kelvin. So you got to make that change. Okay, so here's our problem. A sample gas has a volume of 2.80 liters at an unknown temperature. When the sample is submerged in an ice water at temperatures equal to 0.00 degrees Celsius, its volume decreases to 2.57 liters. What is the initial temperature in Kelvin and degrees Celsius? So we need to write down what we're given. So we need our initial conditions. So our initial volume, V1, they're telling us is 2.80 liters. And our initial temperature is unknown, so that T1 is unknown. That's what we need to find. They then tell us that the final temperature that it is decreased to, so the T2, is equal to 0.00 degrees Celsius. And they tell us that it decreases to a volume. So our V2 is equal to 2.57 liters. So our liters are the same, so we don't need to worry about the unit for volume, but we need to convert temperature from Celsius to Kelvin, and that's easily done. You always convert from Celsius to Kelvin by adding 273.15. And so 0 plus 273.15 gives you 273.15 Kelvin. So there's our Kelvin. And so we need to make sure that because we're adding and subtracting, we have to look at the decimal places. So the least number of decimal places, our answer should have the same number. So we have 2 here, 2 here, so we should have 2. So we keep everything. Good. Okay, so now that we have our temperature in Kelvin, now we can plug it into Charles's law. So remember that Charles's law is T1 V1 over T2 V2. And we're solving for T1. So we want T1 by itself. So we multiply both sides by V1. And so we get T1 is equal to T2 V1 over V2. So now we can plug in the values. So T1 is going to be equal to, so T2, which is 273.15 Kelvin, okay, multiplied by V1, which is the 2.8, so 2.80 liters, divided by V2, which is 2.57 liters. Liters cancels out, leaves us with Kelvin, which is temperature. So that's good. So right away, we're going to get our Kelvin temperature. So now all we need to do is calculate 273.15 times 2.80 divided by 2.57 equals. And we get a temperature of 297. So this is going to be equal to 297.595. So 595, and that's Kelvin. Okay, and now we need to check our sig figs. So our answer should have the same answer as the least number of sig figs. So this has 5, this has 3, this has 3. So our last significant digit is 1, 2, 3. This 7 here. But we're gonna keep this because we still need to do one calculation to get Celsius. Now to go back to Celsius, we're gonna subtract 273. So we take the 297.595 and we're gonna subtract 273.15, and that'll give us the Celsius. So subtract out 273.15 equals, and that gives us 24.445. So that gives us, so that's Kelvin, and that gives us, what did I say? 24.445. So 24.445 degrees Celsius. All right, so now I need to make sure I have the right number of sig figs or decimal places for my answer here. So I said here that my last significant figure is the 7. So I underline that here. So remember, these decimal places do not count, right? Because my last significant digit is the 7. So when I subtract this out, I have 2 sig figs, but I have 2 decimal places, and I have 0 here. So I'm not allowed any decimal places here. So my final answer is 24 degrees Celsius. And this answer is, I need to round the 5, so that's going to be equal to 298 Kelvin. And so that's the answer. Those are the answers to this question. I hope this was helpful, and I hope you understood and it was clarified a few things. If you like this video, share the video, make a comment in the video, subscribe to my channel, and hit the notification bell so you can be notified for other videos that I put out. Thanks for joining me, and I'll see you next time.